Assalamualaikum, welcome back to my channel Learn with Your Buddy, and today I'm here with another video of our Discrete Mathematics series, and today we will learn about logic and propositional logic. Okay, so first let's see the statements and propositions. Well, a statement is a sentence that is either true, and for example we can see that 5 is a prime number, that's true, and 7 is an even number, that's false. Well, we can see that, let's say this like I am a girl, it's true, and I am a boy, that's false. Okay, so it's just an statement. And then not a statement. And what is not a statement? That is close the door. Okay, so yeah, it's not an statement. Okay, and then we will go for proposition. Okay, a proposition is a logical statement that has a definite truth value, and so every proposition is a statement used in logic. Okay, so now let's know about logical connective. Let P and Q be the proposition. Now here, not P means not, that means negation. Like for example, like it is raining is positive, and it is not raining is negative. Now P and Q, now that means we need both to be true, like I study and I pass. For example, I don't study and I don't pass, so both needs to be true. Now P or Q, now at least one needs to be true, like tea or coffee, they both are drinks, but they both are true. And then P drives to Q, it means implies if P then Q, like if I study then I passed. Okay, if I don't study then I don't pass. Okay, and then we have if, that means both same true, like P is true if and only if Q is true. Okay, we will do more practice on this. Now here let's take the truth table. Here not. Okay, so if P is true, P not is false. If P is false, then P not is true. Now and P and Q, now if P and Q are true, then it will be true, and P and Q are true false, then it will be false. I mean, if one of is false, then it will be false. Okay, now we'll look for OR gate. Now if both are false only, then the result will be false, otherwise it will be true. And then implies. Okay, so here if Q is true, it will be true. If Q is false, it will be false. But here if both are false, then it will be true. So yeah, it depends on Q and if both are false. All right, then we have tautology. Well, it's a formula that is always true. For example, P or P naught. Okay, so if P is true, P naught is false. If P is false, then P naught is true, and then one of these is true, so the result will be true. And then we have contradiction. Well, it's a formula that is always false. For example, P and not P. So yeah, here they are always false. And okay, so sorry, actually here. Okay, now, so if you guys feel any problem while doing this, please go to the back of this video and then watch it again, and then solve this tautology and contradictions and so on. Then we have contingency. Now sometimes true, sometimes false. For example, P and Q, like logical equivalence, there are two expressions are logical equivalent if they always have the same truth value. So yeah, here we can see that whatever is P or not P, but it will always result what is in Q. Okay, so that means logical equivalence. And you guys will be more clear when we will we will do some practice on this. So yeah, after that we have laws of logic, De Morgan's law. It's very important. Okay, for example, if P is hot and Q it is sunny, and if we see not, then means not hot or not sunny. All right, we will also practice this law in our upcoming videos. Okay, then we have predicate logic, and here we can see the quantifiers. They are like A and E are upside down. Now propositional logic works with whole statement, and predicate logic includes variables and quantifiers. A predicate is a statement containing variables. For example, P of x, x is even, Q of x, x is prime. But we will practice that. Now universal quantifiers means for alls. Okay, for every x is even, that is usually false, and for all x and x square is non-negative, that's true. Okay, if you guys are not getting it, just remember this and we will solve and we will practice more about this. And then existential quantifiers, that means there exists. Now there exists an x such that x is even. Okay, that's true. Now in example you can see that whatever the number is, if we put a square on this, then it will be positive. Okay, like x square is equals to 4. If 2 is negative, it doesn't matter. So yeah, that's all for today, and please see this video for more times to remember this, and we will solve problems about this in our next video. So till then, stay safe, take care, and Allah Hafiz.